Alright, so welcome to Academic Digest class. So what we are doing today is chapter 1 of your second semester physics, electrostatics. So let's be fast with it. Let's try as much as possible to be very fast. So we see that electrostatics is the study, or we say it's the branch of physics that deals with the study of stationary or slow-moving charges. Regularly, we say that electrostatics is the study of charges at rest or slow-moving charges. So we say that electrostatics electrostatics is the study of stationary. And another name for stationary, if you don't call it stationary, we say it's charges at rest or slow moving charges. So why we add slow moving charges is that you definitely know that there is nothing at rest, if you are being honest. So everything definitely moves. So when you think of it as charges at rest, you know that it's simply charges that are slowly moving. So if we know that, we progress. So I want to quickly round up chapter 1 and chapter 2. So we normally progress if we are learning this. Before I start going deep, I want you to know that there's something we call electric field lines. And that electric field line, I'm not supposed to introduce it here, I'm supposed to wait till chapter 2. But it's important because as we are doing things, you see us trying to say things like this one, light poles and light poles repair, or light poles attract. So it's important for me to touch this electric field line here so that you know what it means. So electric field line. So the first thing I thought about is what electrostatics is. So the second thing is what we call electric field line. So I normally define this simply to my students as an imaginary line. As an imaginary line which is used to describe the direction of electric field. It's an imaginary line which is used to describe the direction of electric field. Full stop. You can also say it's an imaginary line which shows the direction of electric charges. So if you know this, we can now go on to now go back to this, because we cannot talk about electrostatics without talking about charges. So we move on to what we call types of charges. So there are basically just two types of charges. We have what we call the positive charge, and we have what we call the negative charges. And we know that in our secondary school chemistry, they told us that anything plus means metals. You can see this as ions in physics. And why anything negative is ions but electrons, negative charges. So if you know this, let me show you recording. Okay, it's recording. So if you know this, I'm trying as much as possible to be very calm, as much as I want it to be short, but we'll go on. So if I know this, the next thing is to illustrate laws of electrostatics, or you say properties of charges. So if you don't call it, let me not move to laws of electrostatic yet. Let me just base on this property. Let me refer it as property or the first law of charge. So properties properties of charges slash first law of electrostatics. So the first law and first property of charge is that you need to know that A, like charges repel, while B, unlike charges attract. Unlike charges attract. These two give you the first law of electrostatics. So, but under properties of charges, we still have that these charges, the positive charge is the origin. So we can say that electric field originates from origin, and the cause of electric field is because of presence of charges. And I want you to know that the way you see in real life mass as body, in this study, see charge to be equal to mass. And when you see acceleration in your normal day-to-day life physics, see for electric field, see electric field intensity to be the same thing as acceleration. Just see it that way. We've not gotten to chapter 2 where we start doing much of this. But one thing you must understand is that this chapter 1 and chapter 2, they are very related. So positive charge, or you say charges move from the positive terminal, from the positive axis. So positive charge is the origin, or positive charge is the origin of charges, of charge movements, or of electric field intensity. Why negative charge is the end point. So charges So these are the 4 major characteristics of electrostatics. There could be more. We have much more than this because we can elaborate each of these. But I want us to stop here because I'm trying to make sure this video is short so that we can move to the calculation aspect. But why I'm taking time to do this is that sometimes students, when reading this course, it's as if they're trying to say so much there. So let's claim and go back to how charges are made, the making of charges. So we normally say that in production of charges, so we normally say that production of charges production of charges is one that involves one, by friction. So you can produce charges by friction. 2, by contacts. And you need to know that this friction and contacts, they are all classified as charging by contacts. Then 3, by induction. So if I know this, the next thing you need to know is that, so you need to know this. So the next thing you need to know is, there are questions, there are objective questions that always tend to ask you, glass rod and silk, what type of charge does it produce? So the type of charge it produces is classified under positive charge, and that of ebonite and 4 is classified as negative. Now plastic and 4 classified as positive. So you need to know this for the sake of your objective. So I'm supposed to be having class with my students today. Well, I just decided to do this first. So if I know this, you now need to know that when you rub this with silk, it shows you that there is repulsion. So you say it's positive. And when you do this one together, it shows you repulsion as well. These two, rubbing it together, it shows you repulsion and together as well. But this was now said, okay, let this one fall under negative and this one under positive. So you need to know that. So, and if that be the case, a question can come, how do you find charge? How do you test for charge? Testing for charges. Testing for charges. And the only way you test for charges is when you get repulsion. So when you get repulsion, that's when you know that that particular charge is negative. So because on the part of attraction, even neutral charges can be attracted because there are positive charges inside it. So we say that when we get repulsion, that is the true test of charge. So if that is the case, we'll get there, but I'm just trying to touch it in order not to skip anything. So let's progress to looking at certain questions we have here before we further. So questions. So we have a question that says, my friend,
Sir.
Are there students downstairs?
Sir.
Are there the other students are there downstairs?
They are like older students, they are not somebody.
Okay, just let's do the class downstairs.
Okay, sir.
Yes, so it's best we stay downstairs because the lady here, the lecturer, will soon come and lock you.
Okay.
I'm coming down.
Okay.
So the question here says a positively charged glass rod. A positively charged glass rod attracts a suspended object. A positively charged rod attracts a suspended object. Can we conclude that the object is negatively charged? Yes. So if it attracts a suspended object, it attracts because they are of different, they are unlike charges. They are unlike charges. But you need to know that neutral charges can also be attracted by positive charges, because inside that neutral charge there are some protons inside it. So we can't conclusively say that it is a negative charge. Rather, we can say that it is a negative or a neutral charge. That is why I say that attraction is not what you use to test what charge is, but repulsion. Once something repels, you definitely know that, okay, this charge is negative. Yes. So if, for example, I bring a charge to a positive charge and it repels it, I will definitely say that this charge is also positive. And if I know that this is a negative charge and I bring something and it repels it, I will say that this is a positive charge. But attraction can happen to even neutral charges. So if I know this, let's say a negatively charged ebonite rod repels a suspended object. Can we conclude that the object is negatively charged? So like poles repel. So yes, definitely it is a negative charge. That's why it repels. Once something repels something that is of its kind, know that that charge is the same thing with that one. I hope you understand. Calm down and think of it. So what I'm saying is this. See what I'm saying? Why I'm taking time to do this is that the calculation part is always simple, you solve. But this part, if you are reading it sometimes, it tends to confuse students. So that's why I said, let me take my time and see if I can simplify this one. So for example, if I have a positive charge, just like in our chemistry, they tell you that metals give away charge, give away the electrons and become positively charged. So anything positive is always on the giving end. It's moving out, moving out, moving out, moving out. So if I have another positive charge, you see that something will move out, move out, move out, move out. And as it's moving out, notice when these two come and want to meet each other, this one will not tend to move this way. Instead of coming to it, it will not tend to move this way. And this one, the same thing. So when you are moving out, nothing should move in. Positive charge does not have the ability to take something in. So when two positive charges meet, it is moving out, two of them hit each other and move out. So they can't attract. Are you seeing it? But if, for example, I have positive and negative charge, you see that as this one is moving out, this particular one does not move out, rather it accepts things. So you see that this will go on to move into this. So you see this. So the same thing with this one takes things in. So since this one moves out, it's moving into this. So that is why you always see when they draw this thing in some textbooks, after the drawing, you come and see something like this here. Then you come and see on this one, something like this. So you need to know this. You need to know this. And for a negative charge, for example, two negative charges. Because this one only accepts. There will be no connection between the two of them. So that is why we say that. If I bring, for example, a charge I don't know to a charge that I know, let's say negative, the minute it hits, it must repel. I know that this charge that I brought that I don't know is the same. Let's say I don't know this charge, but I bring it together and it's not attracting, it's repelled. I know that this charge is the same with this one. The same thing with this. But the minute I bring it together and it attracts it, let's say I don't know this charge and it attracts it, that means this charge could be either negative or a neutral charge. So we say that attraction is not a test of charge, but repulsion is the true test of charge. So if I know that, you also need to know that anytime, let me not forget, you also need to know that anytime your force, let's say you solve during the course of this electrostatics or electric field or this second semester physics, electricity and magnetism, if in the course of your study you ever get your force to be negative, let's say you get -2 or negative anything, don't ever say that you are wrong. No. Rather, what you say is that for the fact that it's negative means attraction. So your force is an attractive force. But if as you are always solving, you are getting just positive, know that your force is a repulsive force or repulsion. It's a repulsive force. And that leads me to the part where I need to tell you that in the course of this electrostatics, anytime you are considering the charge a body possesses, because of the electric field, it is F equals to NA. But if you are considering the force on a body or on a charge, I'm not using a body now. So force on a body of charge or a charge due to its electric field is simply MA. But when that force or If it's weight, it can be mg. But when that force is happening due to electrostatics or electric field, or maybe there is movement of charges inside, so it has engaged, that particular force will be equals to the charge and the electric field. So anything that has to do with charge making movement in an electric field, the force is this. But the force possessed by a charge due to its state as that in an electric field, but it's not moving, that force is this. So but the minute is just like, I know that there is tendency for a body to take part in charge, for a charge to take part in charging or take part in attraction or repulsion. That tendency, this is the force there. But on account where that charge starts attracting or exhibiting, this is the force. That is why you need to know that NA is equals to QE. You need to know this. That is what I mean. So even if you don't put it this way, if this will confuse you, if this is going to confuse you, what you simply need to do is to say, naturally, once I'm talking about charge, I should have F, force equals to the charge. Charge here, I'm seeing it as mass. And then E here, I'm seeing it as acceleration. That is change in direction of the charge. Or you say how strong or weak the charge is. So, or the pull and push, anything that happens to this charge once it's moving is this electric field intensity. So it's the same thing as saying, since force, I know force from Newton's second law to be MA, so it is equals to QE. So if this particular understanding is hard for you, just remember this. This is the law, or the actual law governing the force of a charged body or of an electric field. So it is from here you now see that they tell you E means electric. Sometimes they call it just electric field, or they tell you electric field intensity. Don't confuse it. Electric field intensity. And then Q is for charge. Are you seeing it? So you need to note that YF is for force, or you say M is for mass, A is for acceleration. You need to know this. If it's where they are talking about G, acceleration due to gravity. So if I know this, let's go back to the question. See if we can answer all those questions, all these kind of questions now. They are not calculation, we've not started calculation. But the good thing about this kind of question, answering it, is that it helps you with objective questions. They can give you an ebonite rod with 4 will produce what type of charge. You will definitely know because you have this class that is negative. And they tell you a glass rod with silk will give you what type of charge. You know that it's positive charge. So this is the idea, the concept that this class helps you fulfill. So it's not everything calculation to prepare you for the objective questions that look simple, but you need to just seek and get your mark and go where you're going. So the next thing we need to treat, I'm trying to remember. Okay, let's look at the question first. The question will guide us. Okay, they said draw electrostatic field lines. Draw electrostatic field lines. Draw electrostatic field lines. For two nearby positive and negative charges. Draw electrostatic field lines around A, two nearby positive and negative points charges. B, two nearby nearby positive charges. C, 2 nearby negative charges. So this is where we got done with this question. This will be the last for today, so that we can go and have our class. So answering A, the answer to A is simply 2 nearby positive and negative charge. It will be in such a way that you have positive, because positive points out. So negative can be up here or down here since it's negative. So in such a way that these two cannot give each other anything. So immediately there is a charge that wants to go this way. Immediately this negative is here, it will attract it. Now this moves in this form. So let me just use one. You see it? So this one is on the receiving end. So if you know this, on this other end, you show this, show this, show this. So you also need to know that if, for example, I have a charge here, I have like 3 charges pointing this way, and I have here 2 charges moving this way to negative. It means that it's pointing down here, sorry. So the more line of field, the more electric field line, this is electric field line, the more electric field line we show means that there is more charge here than this one. So I put 2 to show that I want it to be equal. So you need to know this. So if I have this in mind, that is for 2 nearby positive charges. Now for 2 nearby positive and negative point charges. Now for the B part, that is 2 nearby positive charges. It will simply be positive, positive. This is how it will go. Some textbooks you see something like this. So, but because of the fact that they are positive, this one will end up like this. The same thing here, so they can't attract. You see, this one will turn up, this one will turn down. Even if there's something that is supposed to come here, because of the fact that they are not going to attract, it will still come down or go up. That's why I'm leaving it at this. So for 2 nearby positive charge, this is it. While for 2 nearby negative charges, C, you see that once you place this and place this, it's not like when you are showing the negative, everything goes inside. It's not like when you are showing only negative going inside or this way. No, because there's a charge here, as they are trying to contribute, they will repel. So it will simply be in such a way that this will be in the way of so there you have it. So for C. So we're going to stop here for today because the rest of the questions are ones that require us doing calculation, and we'll do that. We'll record that one during our tutorial class. So they said, describe in detail how you charge an econoline rod by direct contacts, then by induction. So if I have this to be the rod, by direct contact, if I have positive charges here, I have to make, for example, let's say I have a sphere. I have to make it touch. I have to make it touch. And by the time, okay, I'm coming. Okay, I'm coming there. Thank you. And by the time they are done touching, so this is before. The minute they are done touching, after, I need you to know that anything contacts will leave. This will have the same 2 charges, and then this sphere you see here will now be rubbed off of these 2 charges. It will still be positive. But if it's by induction, let's say I have, so normally, This can be negative. If it's negative, by the time you leave it, will still give you negative charge. So what it simply means is that by contact, whatever charge you have, on the time it leaves, it still leaves with the same type of charge. But if this is by induction, let's say I have negative rod, here, negative. By the time it doesn't need to touch. By induction does not mean it does not have to touch. So let's say this is here, this is here. So by the time you engage these two by induction, after, so this is before. So after, you now have a negative rod and this sphere will be positively charged. So thank you very much for this. Bless. Remember to subscribe.